and I think we can start.
Okay, well, I would like to welcome everyone who is coming today for our webinar, the seventh webinar. And I would like to open this webinar with a little bit presentation about Emanate. So Emanate was created in 2008, February 2017, sorry, 18, by 2017 graduates. So the idea was that we want to share informations about our experiences in internships. And so that's why we decided to have webinars. And until today, we have, well, this is going six presentations with eight people sharing their experiences in webinars. We also had Marcia from a previous batch that was presenting us her real project in her company as well. And then we created groups in Facebook and in LinkedIn. And at the beginning, it was only for 2017, and now we have invited all of you from all batches to join us. And yeah, thank you very much for having joined our group. And for those who haven't joined the group, simply type Emanate and you can find our logo there, and you're very welcome to join us. So our target is actually just to collaborate because we are the mini international graduates. We have the same experiences in the classes, we have the same environments, and probably most of us are looking for the job in the same sectors. So I think it is very valuable to collaborate together to share our experience and yeah, probably to support each other. We have webinars at the moment. We will come up with a newsletter that we will send to you regularly, and we have the idea to work on podcast. So if anyone is interested to work on podcast, so if you're wondering now that you're in Emanate and how will you collaborate or how will we collaborate, we collaborate by sharing, by supporting, and by inspiring others. So we want to complete each other with our experience. So we share what we did, we share what we know, and then, for example, if I need someone who is expertise in like solar or in wind, I know where to look for support. So this is the second purpose of Emanate. And then we look into inspiring each other because not everything is easy. Like especially when you're into new projects or you're looking for a job. This is also the media where you can actually look for inspiration from other batches, from other graduates. Yeah, so Emanate is the place for you to come and you can ask to other members how to advance in your professional career or professional life. Yeah, so basically that's Emanate, and I'm so happy that now you're already in the group, yeah, already here and listening to this webinar. And the community is exactly how we make it. So we invite you to create this community together. If you're wondering exactly intangible things what you could contribute, you can actually write articles and you can contribute to our newsletters. You can also be our webinar speakers. You're very welcome for that because we look for speakers for every month. And if you don't want to be on a webinar real time, you can also be a podcast speaker. And maybe in the future we will also make websites. Then you can also contribute to that. So yeah, that's Emanate, and I hope you can benefit from what it is, and you can contribute to that. I give it to Andre now.
Okay, uh, thank you, Astu, for the introduction.
Mm-hmm.
And we have here Cesar Nicolas Rodriguez that will present our today's topic with titled Advanced Analytics and its application in the industrial sector. in the energy efficiency. Uh, so I think we can start. I give the yeah, Cesar. You can start your presentation and enjoy.
Okay, thanks, Andre. Thanks, us too. I'm going to share the presentation with you. So just well, I've done a very brief presentation about energy efficiency and advanced analytics. Please let me know. I mean, at the end we could have some questions, or if you want. I mean, this could be like a very informal conversation. I just want to share a little bit what I have learned in my internship. So, well, I would start with this topic. Are you listening to me? Is it okay for everybody?
Yes.
Yes. Okay. Well, first of all, I would like to start with why do we talk about energy efficiency? As we all know, there's energy-intensive industries such as chemical, oil refining, mining industries, which their their cost of their OPEX in energy is quite high. Well, high would represent at least 5% according to Didier Baspoof. But well, in this article, I have found that it's at least 7% of their operating costs. So there's a need of improving energy efficiency within the industrial sector. And even though we have, well, companies have done a lot of it in terms of replacing equipment or in terms of going through a new technology, there's still a gap in terms of what the potential of energy efficiency in the industrial sector. And this is why we're going to talk advanced analytics. But before going to advanced analytics, I also would like to introduce what is called Industry 4.0, or the fourth revolution in industry. As you might know, well, first we started with this mass production of stuff like Ford when they started producing a lot of T's, Ford T's. Then we started automating the production lines, and then nowadays we are talking about cyber physical systems where big data and advanced analytics, IoT, are are part of this revolution. And just talking about big data and advanced analytics, nowadays we have a lot of sensors that it's bringing us valuable information about the process. We have done it in order to control processes, but nowadays we could use this data in order to improve the performance. So that's why we talk about artificial intelligence and machine learning. So artificial intelligence, the concept was introduced by Alan Turing. He's the father of artificial intelligence somehow. And with this universe of artificial intelligence, we have what is called machine learning. And machine learning is just a set of algorithms which performance improve as they are exposed to more data over time. But we have to be aware that all these models are going to be some historical data. So when a new condition arises, oh, this is when uh, humans would take decisions. Normally, they would take data-driven decisions, as I show in this picture. This is a guy that is just taking a decision, but as you could see, it seems to be like quite full. He's just throwing a die, and he's saying, "Okay, if it's bigger than 4, it's yes. If it's lower, it's no." But normally, this is how it works in industry because there are technicians, engineers that they really know how a process works. So they just use rule of thumbs, and this is the way they are working on. But if we go to the physics or to the what is some data of these processes, we could find the reason of why they are doing this. So how we're going to drive value from data? Nowadays, we talk a lot about data scientists. These people who mainly are software developers or which are working in collecting the data, on processing this data, in transforming this data in a way in we could analyze it. But also in the other part of the process, we have the domain experts. We need to couple both of them, data science and domain experts, in order to translate the analytics results. So in order to maximize the value of these data insights, we have to get these people working together.
Of the process, we have the domain experts.
Uh, it's okay. Sorry. Okay.
Yes, please continue.
Well, so we have this. We need to have these people working together. So as well, we all pursue the same master program. So we are energy experts somehow. So we could work with these data scientist people in order to improve. Well, in this case, we're talking about energy efficiency, but we could talk about reliability. We could talk about availability. We could talk about production. So a data scientist is a guy that really knows how to treat, to collect data, and to process it. But in order to translate this into real results, we need the other part of the equation, which are the domain experts. In this case, we're talking about energy engineers, but it could be process engineers, manufacturing engineers, someone that just has an expertise in some field. So what we would commonly have, or what we commonly do in order to start to deploy advanced analytics, is first of all understanding what our process. So a common process in industry, we would have input parameters with we would have some settings for this process. We would have some raw material to go through this process. Then we are going to have the transformation of this product or of these raw materials to a final product where we're going to inspect the quality of it. We're going to inspect the production, the amount of units being produced. We're going to inspect to review the yield, for example, the grade. So in order to control this process, we are going to have different process parameters which we are going to be normally measured to be pressure, temperature, pH, water cut, whatever what we could measure. It's and what we are able to adjust, like a flow rate. It's what we are going to be measuring. And in terms of energy efficiency, we're going to have a key performance indicator, which, as you might know, it's the specific energy consumption. So the specific energy consumption would be our KPI for reducing the energy consumption and improving energy efficiency in our processes. So for this, we're going to go to a more technical detail, what is the energy assessment, and how to start deploying, I would say, descriptive statistics. Here we are not talking about analytics. I would like to show you this the use of descriptive statistics for energy efficiency, because everybody could do it. Well, if you're working in energy management, or you're working in industry, or you're working in the energy field, you could deploy these kind of tools without any other expertise. So what we commonly would do is to analyze our KPI, the specific energy consumption. In this case, I have done an histogram of kilowatt hours per ton. Well, this could be per kilogram, per grams, depending on the unit you would like to use. And as you might know, here in the y-axis, we have the frequency for this KPI. And what are we going to analyze for these histograms? If we recall our Lomix lessons for the PM3 guys, we could analyze the shape. We could analyze if it's, first of all, if it's normally distributed, or do they skew left or right, and then started asking us or having some conclusions of why this data is skewing to the left, why is it skewing to the right, in which conditions it is happening. Then we could also go to the spread of it. Are data tightly clustered about a certain value, or do they stay within set of limits? This could be the limits of the process. If they do not respect the limits, why do they not respect the limits? So this is just how we could assess the variability of our KPI, specific energy consumption, and this is how just by simple data visualization and descriptive statistics we could get an insights of our process of our process. Sorry. Then we would have, as you might know, well, time series plot. Well, just to help us to evaluate patterns and behavior over time. For example, just before and after a process change. So y-axis we would have our KPI, and we would have in the x-axis time. How is our process behaving? Then in the right side, you would have, or you might find, a scatter plot, which I would call it a load curve. The y-axis you would have the KPI, the specific energy consumption, and on the x-axis you would have the production, or well, the mass in this case. So we are going to analyze the potential relationship between a pair of continuous variables. So in the industry, normally, if we tend to produce more, we tend to reduce our specific energy consumption. That might be the most common scenario, but for some processes, this load curve is not like this. It's completely just some flat points or just a flat line, or it might be a different shape. So here, but normally they would behave like this, like a load curve. So other tools that might be useful for this energy assessment would be box plots. I didn't put them in the presentation because I found that really with histograms, scatter plots, and time series, we could have the first insights of our energy consumption and drive some conclusions from it. So after doing this energy assessment, what would we have? Is we are going to be able to filter data. Why? Because we are going to be able to identify seasons, for example. We are going to be able to eliminate transient conditions. Maybe we are talking about when we are studying a process, when we are in the commissioning part. It's not the same as where we are producing in the stable regime. And also sometimes we might have some noise coming from the measurement devices, noise coming from the process itself, or sometimes we might have abnormal behaviors, again because of the measurement device, if it that one is properly working, or maybe just because we have an issue within the process, which does not happen usually. Then after filter this data, we're going to establish our baseline. So we're going to say, okay, which is the representative energy consumption of our process? And from this, we're going to establish a target. We're going to perform a target placement. So we could do it. We could do it with the time series, but as you could see, it's quite erratic. So for me, it's easier to use histograms in order to target to place the targets. So for example, in this slide, I have put the target just in the middle, in the mean of the process. This is something that it's more like it has to be process sensitive. We are not going to target the left side part of the histogram because it's not real. But we have to analyze this data. Maybe also, if you see, it's not only the mean, but it's also the most frequent value. So in this case, it has sense to do this. But we could place also different targets and say, okay, we could have a conservative scenario in which I expect to achieve just 12 kilowatt hour per ton of 12 kilowatt per hour per ton energy specific consumption. Or I could go to a more challenging scenario, which I place it into 9. And from this, we would estimate our energy potential savings. So Before going to model development, I don't know if you have some comments, if you have some questions regarding this part.
Yes. So just little question. So when you say the target is the KPI, are those
Yeah,
are the same thing?
yeah, it's always the KPI. We are always working with the key performance indicator, uh,
Okay.
uh, and this would help me to introduce why is it important to just to establish this key performance indicator, because for developing our model, the first task is to establish this KPI. So we
Okay.
could not go through the following steps if we haven't established a KPI. And this might be something easy. You might say, yeah, it's just a ratio of the energy consumption and the production. Yes, it's just that. But within industry, you might have several measurements that would relate the energy consumption. I might say it's not. You might have. I could, if we are talking about electricity, maybe this is measured at different points. So you could be adding them, all the points, and getting your total energy consumption. Or maybe you have one point which is measuring the total consumption. And then sometimes you might find that just by comparing this, you might find some differences, and you would start wondering why do we have these differences. So just from this point, you are starting to know your process. You're starting to know more about it. And then, well, as to is this only your question, or
Yes, yes. That was my question. I just wonder if KPI is equal to target. You can continue.
uh, and then we're going to go through the relevant parameters. The relevant parameters.
Cesar, I have a question, if it's
Yeah,
okay.
yeah,
Uh,
yeah.
so, just for me to understand, maybe I missed the part, but for example, you showed the graphs in the slide above, and I was trying to understand for what particular case were these results for, like which case are we talking about? Where did you do this energy assessment?
Okay. I could not say the place, but I could say
Yeah,
some.
like just a
I could say
general
some.
description to
Yeah,
understand.
description. Yeah, sorry. In terms of the context, imagine that you're producing a polymer.
Mm-hmm.
So for the production of this polymer, you might have different processes, and from this process, you might have a consumption of it, and you would have the production of it. So
Mm-hmm.
we are talking about pro. Uh, yeah, we're talking about the examples in the chemical industry. We're talking about examples in the food industry. Maybe this could also work for the food industry. They could also work for the manufacturing industry. How much energy we are consuming when producing a certain product,
Mm-hmm.
and this is the case.
Okay.
So I would say that this would be the context. The context is whenever you're producing something, you are going to measure how much energy you're consuming and which is your production output.
And is this when you say you're measuring the energy consumption, is this like the total energy consumption of the plant, or is it like of specific machines?
Yeah, this, for example, could be done. Yeah, at a higher level, like a plant. Yes, it could
Mhm.
be done, but it's easier to start with a process. Let's
Mhm.
say that we have a plant where we're producing. I don't know, not only polymers. Well, when you produce polymers, you might have different kind of polymers, for example. So for
Mhm.
each of them, they might not follow the same process.
Mhm.
So it would not be useful to just measure the whole plant because you're not going because each of the products are different. So
Mhm.
the specific consumption is product dependent. So it's better to go and just target one process, one specific product, for example, and
Yeah.
then you
Okay.
understand just the insights for this process, and you might replicate the same for all of them.
Mhm. Okay. And what kind of tools are you using when you do this energy efficiency analysis?
Well, we could use same tools as in terms of software. I mean, you could use Excel, you could use Minitab, yes. But since we're talking about handling millions of lines,
Mm-hmm.
because here we are talking about handling maybe 3 years of production, and these 3 years of production, it's, I mean, the production and the energy consumption is measured, let's say, at least once per hour. So we're talking a lot of, in terms of a lot of data. So nowadays you might find um, companies which are developing software solutions for this. So there are
Mm-hmm.
companies in Belgium, in France, which are developing artificial intelligence platforms in order to have these visualizations and in order to do this analysis.
Mm-hmm. Okay.
Yeah, sorry, I could. I wanted to put the logos of the companies, but also I thought about it, and it might it might not be a good idea.
Yeah,
But
no, no worries.
uh, well, what I would like to say is that nowadays there are available platforms that allow you to clean the data, to visualize the data, and to perform analysis in a in a faster way. We
Mm-hmm.
could do this with common and normal tools, but imagine handling this amount of data, performing this analysis for each of them. So we need something that we just in a couple of hours, in an hour, or even in 30 minutes, we could at least have an insight of the process. So yeah, this is just about once the data is prepared, once data is collected, it's started to clean it, to understand it, and to do this, you might need a platform. How could I say it? A customized platform.
Mm-hmm.
I can answer this valid question. Means when you want to do an energy assessment, you already have to have all the sensors installed.
Yeah, yeah, normal. Yeah, that's an issue. That's also an issue within industry because most of the times, well, not most of the time, sometimes they might not have even measurements. So they want, for example, they might say, okay, I would like to deploy this kind of analysis, but I don't have a measurement device in my process. So the first step is to install a measurement device
Yeah,
because we do not improve what is not measured. So
exactly.
this is the first step. Or sometimes they must say, okay, which parameters of my process shall I measure? And you might help them, but they are the ones that know their process. They are the ones that might know better than you which uh, which parameters we should be measured. Uh,
Okay. All
yes,
right.
all this could be done only if data is available. If no data is available, well, and then we have to also verify the quality of data because it's not just of having data, but maybe also that's why when I say the output of this energy assessment is filter data, it's because you might find all these. Okay, we have data, but there's noise in the data, and you have to identify it. And sometimes it's not because there's noise, but sometimes, for example, the measurement device is simple, it's not working or it's not power on. So you might have a lot of blank lines, and you might just take it out because these lines are not going to be useful for your analysis. So, well, I know this if you're thinking like in Excel sheet, it's quite shitty. It might take a lot of time to do. It might take yeah, and you might not have the same insights.
Okay.
Um well, I don't know if it's another question regarding this part. No.
I think it's okay. You can move ahead.
Okay. So then we're going to go to the model development. As I said, okay, we have one process. We have understood our process. We have identified which parameters are relevant. For this, within industry, there are some methods that might be useful for for performing somehow a root cause analysis. You could use some lean manufacturing techniques for identifying these relevant parameters as well. But also there are some artificial intelligence machine learning tools or artificial intelligence tools that might be useful in order to identify these parameters. Then you might choose a learning set. If you remember, we have already established a baseline. We have already filtered, cleaned the data, and we have said, okay, this is during this time the data that I collected, and it's representing the real condition of my process. So the next step, the fourth step, would be, okay, which algorithm I'm gonna use. In this case, I have just put an image of a simple linear regression model. You might have a predictor and a response. But believe me, this simple linear regression model, it could it could work in industry just by identifying which parameters are affecting the process, just by cleaning and filtering the data and identifying which is really representative of the process, and just by performing a simple linear regression model and testing the quality of it. If you remember, this R square parameter might tell us if it's good or not. So, for example, in this case, we did have 96%. All I took these images from Minitab actually. So, if it's working properly, then we have to test it in the process. If it's because something is developing the model, and then we have to test it. So uh, that's why you might find these arrows between relevant parameters and model testing, because it's a kind of a loop. So the model is working. If yes, well, it's done. But if not, we have to come back and see, okay, which parameters are really affecting the process. Is it clear for everybody for this part?
Yeah.
Yes.
Do you have any question? Please go ahead. I want to do like more like I mind doing this like with a couple of beers in a sunny day. But I'm talking about what we have done. So please go ahead if you have any questions. If not, I will continue. Well, once we have already developed our model, we have tested it. Okay, it's working. What is the next step? It's not like people usually say that are going to work alone. This is not the case. Well, not nowadays. What it would be, what you would do, or what companies would do, is normally just a dashboard to track our KPI. So I have taken this image from Grafana. Grafana is an open source tool for developing for dashboards. So it's important to create just a decision making tool, which would help technicians, process engineers, energy managers to avoid drifts and say, okay, we are going to have a dashboard which is going to prevent us uh, for consuming more energy and just to keep us in the target. So you remember that we have established the target. So we have to be within that target, and for that target, we would have a dashboard which would tell us somehow if we are in a good condition, or if we are in a preventive condition, or if we are in an alarm condition. That's all. And with this, we could take decisions within minutes. Well, maybe an hour, yes, normally, in terms of that the communication takes place. But well, this could take place even in minutes. So you might not have a problem, and you might not encounter it after hours. This is the useful, and this is how artificial intelligence is boosting performance, because you're going to identify problems before they arrive, before they arose. Uh, well, regarding advanced analytics against other energy efficiency projects, I do not have experience with common tools for assessing energy efficiency. I have done it just with data. But what I could say is that for advanced analytics, since you're using your data, you don't have capex. You're not replacing or performing a major overhaul of our equipment. You're not replacing a pump. You're not replacing a compressor, you're not improving a boiler. No, you're just maximizing the current asset performance. And also another point is that you are not just taking a snapshot of the performance as common energy efficiency projects. You are taking into account the whole, well, not the whole maybe, but since you have data available, you could take into account the historical performance record of your process. Uh, and then also it's fast to implement because once the model has been developed and tested, you could implement it and see how it works. I mean, in the real process. So you don't have to wait for a replacement or for an overhaul of an equipment. And you might also have quick savings. Why quick savings? Because when you are doing all this loop of model development, you're going to have some workshops with the people that is working on the process, with technicians, engineers, and you might find some problems already. You might find some best practices. You might find some issues as well, but you're making all people work in a team and getting this continuous improvement philosophy. And also it's in accordance with ISO 50001. I don't know not much about this ISO, but I know that they need in ISO they ask you for a tool to monitor your energy performance. So imagine if you are deploying a project with advanced analytics, you're going to get a dashboard. You're going to get a real-time optimization. So you are somehow also complying with what ISO asks for you. But
So let
uh,
me just ask.
yeah,
I have a question. So you said that it allows a real time. What did you say? Real time
real-time.
improvement.
Yeah, well, real-time optimization. Yeah.
Because like the information that we see in the dashboard, uh, it is fed back to the system, or and then it is gonna be our decision to adjust the performance of the systems.
No, it would be our decision to adjust the performance of the system. Well, this could also work in a completely closed loop system where the machine or there's a control device which could
Yeah.
adjust a flow rate or could adjust a temperature, a pressure. That could happen. That could be done. But
Mhm.
in the process industry, there's also sometimes you're talking about working with a high pressure steam, for example. So there are also some issues in terms of security. So it's always, well, it's not always better, but sometimes you might still need someone, or there is still someone that would take the decision. So believe me that just with the dashboard that alert these people, it's easier than monitoring the complete performance of the system. And when I say real time monitoring, is because once the model is developed, tested, and implemented, you would have this in data would be streamed in real time. So the model would be fed in real time, and the dashboard would be updated in real time. So that's why I said about real time decisions.
Okay. All right.
So actually, we can say that this type of a system of advanced analytics can replace a production management system.
I would not say that it would replace it, but it would boost its performance. Because still, or when you talk about a production management system, what do you exactly refer to?
Well, it's an equivalent of building management system for production, seeing what type of production is going on at what time and how much is the energy consumption or energy output depending on the process.
Okay, well, we have to be, for example, I don't know if you know, how could I call it? Yes and no, because sometimes we have to be aware of what is the function of these production management systems. So sometimes it's just like Pi. Do you know Pi?
Yes.
So, for example, in Pub, you're able to visualize data. That's that's wonderful of Pi, yeah. And for that, Pi it's one of the best tools.
Thank you.
But you could stream data from Pi to your advanced analytics platform, because Pi is not going. I mean, within Pi, you are not going to find machine learning tools.
Yes,
Here,
the
here I'm just showing, yeah, a simple linear regression model, but we could have decision trees, extra trees, artificial neural networks, and this is what you might not find in Pi. So what you could have, for example, it's, yeah, Pi, it's going, well, you're going to collect the data, you could visualize it, but you still need the advanced analytics tool in order the model to run. And then you could also visualize your data in Pi. The output of the advanced analytics model, you could visualize it in Pi as well.
okay. So it's basically it can be a complement to a production management system, but not really a replacement to the production management system.
That's it. That's it. And nowadays, there are some companies. I mean, Dassault, for example, which are trying to work to have a solution for each part of the process, from collecting the data up to the analytics part. When you have this, it's completely what is called vertical integrated. So you might have the whole value chain from data collection up to the analytics and even the dashboard part. So there are companies that are working on that, but normally you might find someone collecting the data. You might visualize data in another platform. You might perform analytics in another one, because each of them, they have their expertise. But it's true that some of them could develop solutions for the whole system.
Okay, thank you.
Uh, but there are still some challenges. Yes, it might be, it might not. Yeah, you might not have capex. It seems to be good, but the challenges are still there. And as any other energy efficiency project, you still have the financing barrier. Managers might not have an incentive to allocate resources because they consider energy efficiency as unsexy or not sexy. So they might allocate resources in expanding a plant, for example, of having more production, because, well, sometimes it happens. You might have the organization structure barrier as well. Sometimes they do not have time for doing this. They are running within the process. I mean, they are trying to solve daily issues, a pump, a compressor, a personnel problems as well. So you might have all these, and also change management, because it's also about changing habits and operational practices. So imagine that you're going to arrive to a site where you're going to say someone that has done that job for 20 years or 15 years, I know that you have worked here for 15, 20 years, but now we're going to develop a model that it's going to tell you what to do, and you have to follow this model. So that part is not that easy as well. So that's why we have to take them into account when developing the model. We have to take their opinion into account. We need to somehow make them feel part of it, not just uh, installing a dashboard for them and saying, okay, you are going to follow this. No, it's more about working with people. And yes, there's always the issue of data security, so exposing industrial data. So here, I'm not an expert in this part. So here in this part, yeah, you might have this issue, but also we have to be aware of the value of the data. If you see, for example, just some minutes ago, they asked me about the context of it. If you see a value without context, it's quite difficult to say, okay, yeah, they are producing cars, they are producing solar panels. No, I mean, we have to be also aware of the value of this data. So I just would like to come to the point of change management, because nowadays there's the concern about robots, machines replacing humans. I don't see it that way. I might see it as a robostat, as in the picture in the right. So nowadays we would have tools that would help us to do our job, to boost our performance, or to do more stuff within the same time. Yes, but not replacing completely a technician or an engineer. That's not happening now. And then I would say that data security for this, they have developed ISO has developed also a standard which is called ISO 27000, for example. So there are some tools that might be that could be implemented, or there are some methodologies that could be implemented in order to avoid or to prevent having problems in terms of data security. A local solution could be also in term not a cloud solution but a local solution, not exposing the data to the cloud. Well, each company would take their own decision. And well, that's all for me. Thanks. And as you have seen, artificial intelligence, I don't say that it's a statistics, but this picture clearly shows that it's based a little bit on that part. Yeah. So you have statistics, you put a frame, it's machine learning, and then, well, you say, okay, both of it, they're artificial intelligence.
Mm. Thank you, Cesar. I have a few questions,
Yeah.
if that's okay for you. Um, One of them is if you go to the slide where you differentiated between traditional energy efficiency methods and yeah. So in this case, what do you mean when you say common energy efficiency projects? Like, what's the difference? But like,
Uh,
what are you considering common? Like, what would be the non-advanced analytics ones?
I would say a common energy audit, where they are going to assess the energy performance of a site, and they are going to take a snapshot of that site.
Okay, so where they, for example, go through all the equipments and processes and everything and analyze this and then identify. So the capex comes with a human cost investment, sort of like experts going through the information.
Uh, Humans, yeah, but for these projects, normally they, well, sometimes the recommendations are replacing or performing an overhaul of in an equipment. So this is where you have the main cost.
Ah, okay, so you mean that that involves changing, like making the equipment more energy efficient, but in the advanced analytics method, it's not about making the equipment efficient, but the process efficient.
Yeah, that's it.
Uh,
And what kind of, sorry.
I'm sorry because I want to elaborate on that same question, so I'm interrupting you. I wanted to ask on the same thing because from what I understood, that advanced analytics can actually be used as how do you say, as something that that can be used to fuel an energy efficiency action,
Yeah.
basically.
Well, that's also true because we could do both actually. But in terms of deciding where to invest first, you might do first the advanced analytics. You might improve the current performance of the equipment, and that would give you time and savings in order to perform a major, or for example, changing a technology or of an equipment. You might not do it in a quite short time of period, so a period of time. Sorry, you might do it in maybe months, years. So I would say yes, they are not fighting one against each other. What I would say is you might do one first, and then you might do the other.
Cesar, so to just understand what kind of suggestions there are, I mean, you don't have to be specific, I understand that, but what kind of process improvements does advanced analytic helps in? I mean, because if you're not changing equipments or something, then that implies that, I mean, generally industry might be trying to make the process as efficient as they can already. So what kind of suggestions do you have then in such cases?
when you're working in this type of projects, you are targeting variability actually. So you're going to reduce the variability of the process, and by doing so, you're going to improve the performance of the process. So that's why I came back to this slide of an histogram, because it assess the variability of a process. So you could narrow it, or you could just decide where to work. And you might say, yeah, if you could. I don't know if I answer your question up to here, or
No,
it.
I mean, I understand that you're trying, but like, for example, if you figure out that there is, say, at certain time periods or whatever, the energy consumption is extremely high, but then what does the what does this advanced data analytics tell you at the end? Like, does that mean it gives you suggestions or it helps you identify suggestions? Like, but what kind of suggestions? Maybe is it something like, okay, like, in smart homes they have something like using the washing machine not when the prices are peak but later in the day, like stuff like this. But
Yes.
is it that, or is it like really making the process more efficient?
Yeah, that's what you have said. It's one part. When you start deploying advanced analytics, that would be, I would say, the first savings you might have. You might find
Hmm.
out that there are some opportunities or some scenarios in which your process operates in a better way. That's
Hmm.
the first one. And you might that's what I refer to quick savings. These are the
Yeah.
quick savings just by implemented it. But then the bigger savings, or the final savings, is you're going to prove the process in a not I would not say you're going to optimize the current performance of the process by developing and applying a model. What I mean is that a machine learning tool would be able to handle the data, the current condition of the process, and give you a recommendation in order to avoid not working within the KPI, within the target. So the first one is the quick savings, quick recommendations, as you said, as the example you have just given me. And the second one is this this dashboard. It's going to tell you actions that you're going to take in real time in order to avoid consuming more energy, for example.
Okay. But then in that case, the the machine learning or the data analytics needs to have really good knowledge of what's really happening in the process, right? Because it
Yes.
really needs to be able to identify, if you change this, what happens, and if this happens, what happens. Would that not entail a lot of capital investment? Because then someone needs to mirror this process in a software environment.
Yes, there are some. Well, this might not be capex in terms of infrastructure, but this normally it might be a cost in terms of service. You might
Mhm.
need a platform, and for this you might need a SaaS, for example, a software as a service. So you
Mhm.
might need to pay licenses. You might need to pay access. Yeah, that's part of the expenses of advanced analytics. But you are not deploying infrastructure. So yes, you are going to have people analyzing your process, but this is done just once. It's not something that you're going to be performing on a yearly basis, not for the same process.
Mhm.
Um,
So
I don't know. Maybe if you did this in your internship, right?
sorry.
You did this in your internship.
Yeah,
Did you apply it to a real case in this
yeah,
process?
yeah.
Probably you can explain how you use this and how it can benefit the process during
Uh,
your internship.
what what I could say
Mm-hmm,
is that there was a site. We what I did is it's perform an energy assessment.
mm-hmm,
for a particular process of this site. And by the end of the day, I estimate the potential savings for deploying an advanced analytics solution. That was the part of my internship. Then, as I said, the decision investment takes time.
Okay.
So you analyzed if it makes sense to have advanced analytics, or what would be like the benefit the company would have by
Yes,
using
yes,
advanced.
yes. That's the first step. The first step is
Oh.
okay, saying, should we continue? Should we deploy a solution? Is there a potential for really deploying a solution? Yes.
And what kind of factors help you identify if it makes sense to have advanced analytics implemented? Like what would be the deciding factors in this case?
Uh,
Money.
as
Okay.
as as most of the stuff in life, the finance part. So, how much money are you going to save?
But without having data, how can you decide?
No, for that you need to have data. For that you need to have data. If there's no data available, you cannot estimate the potential saving.
So what data did you use?
The customer data.
Okay. Without having advanced analytics.
Yeah, so it's so the customer they have this process and they have data available and they say, okay, I could share it with you and you let me know which is the potential saving for this process with this data.
Okay.
But
So
like data as in energy consumption data of the
it's energy,
customer.
it's energy consumption, but it's not about just energy consumption. For example, in my case, I had 95 parameters. Uh,
Mm-hmm.
93 of them were numeric, and two of them were text. And for this, I have 3 years of information recorded in an hourly basis. So when I say energy consumption, here remember we are talking about energy consumption, yes, but we are also trying to find which are the parameters that really affect this energy consumption.
Yeah.
So, if I'm not wrong, rather than, for example, in the traditional, let's say, traditional approach to energy efficiency, when we want to change equipments rather than do analysis, we rather concentrate on, you know, we rather instead of processes, we concentrate on equipments.
Yes,
But in this type of analytics, you're rather concentrating on the process than the equipments.
that's it.
Okay.
But it could. I mean, we could have the scenario where we could say, yeah, we have identified that this model of pump is working that better than the other one. Why? And we could do analysis from that also. So it could also happen. It could also give us insights about the equipment performance.
Okay. Well, I
Okay.
have a couple of questions or rather clarifications asked from by people from YouTube, so I'm going to ask them to you on their behalf. First of all, there's a question that I don't understand how you can implement these actions or recommendations without having a change in process.
Ah, no, we're having a change in the process. We are changing. Remember, we have these process parameters, and this is what we are going to adjust. So we are having a change in the process.
Okay, so if I may refine that question a bit. I mean, to just to develop the question. So you are going to take, or maybe just summarize it a bit. You are going to take the data that is coming from the actual process. Let's say the process which has not been modified yet, which is efficient or non-efficient, that is out of the question. And then through this data, you are going to know what processes needs to be refined or what processes needs to be changed or modified, and how are they supposed to be modified.
Yeah.
And then you bring those changes to the process using this data, if that is just the summary.
Yes, that's the summary.
Okay. And the second question is, instead of capex for advanced analytics, we are rather talking about an opex for advanced analytics. Is that right?
Yes, yes, there might be OpEx. That's right, but because since you need a platform, you need to pay for the license, for example. So you might have OpEx, but believe me, I can it's not that expensive.
I have a question developing on the same question of OPEX and CAPEX. As you just talked like around 5 minutes ago, that the most important parameter is the financial output, which is absolutely correct. But when you're adding costs to a process by using advanced analytics, even though it is OPEX, it is a cost. And this cost will incur other costs in the future, for example, replacement of equipments or refining of processes. So how exactly are you supposed to convince the management or supposed to convince the people who carry out the process to indulge in this cost? I mean, or rather, if I might refine it in more financial terms, what is the payback on this kind of actions? Well, I know the payback will depend on how much you
But
modify the process, but on an average, what can be a payback of this kind of action so that the management is easier to convince? It's easier to convince the management.
it's less than a year, the payback. The payback period, yeah, it might depend on the potential saving, it might depend on the process, but I could say that a year maximum, well, around a year, it's the payback period for this kind of solution. And sometimes you might find it in months. Because also the assessment, I would say some figures just to have just to illustrate it. You were going to perform the assessment in a couple of weeks. You're going to perform the implementation working with already with available data in, let's say, 6 months. And from the implementation, you're going to start having results. So from 6 months, you're going to have some results, which by the end of that year, you will at least have half of year savings, which might already pay for the solution.
Okay, thank you.
Is there any more question from our YouTube followers, like
No, that's
audience?
it. Thank you.
Okay. Any more comments from the Google Hangout listener?
One thing I wanted to know is, so could you finish this analysis in like 6 months? The analysis which you did about, when they gave you this data for 3-year data with everything, how long did it take for you to identify that this would be beneficial for them or not?
For me, since I was new, it took me a couple of months. But
Okay.
someone that already mastered and also it's important to have available data. If the customer would not have data, I mean, we could not do the analysis. But this, believe me, this assessment could be done in a couple of weeks, and even rushing in a week. So imagine
Okay.
arriving to a site and assessing with all available and prepared data, and with the correct tool for assessing this data, I might say 1 2 weeks.
And then the tools, when you say the correct tools, are these like machine learning tools, like which take this data and sort of do an analysis on it? Or is this like a preliminary analysis from what people are aware of, sort of?
No, what I mean with correct tools, I mean, yeah, it could be the platform that you are using, but nowadays there are plenty of them which are user friendly and which an engineer could use. If not, you might have the data scientists working with the scripts in Python or in R in order to do the same.
Mhm.
So just when you code, there's people that it's very good at it, and they code quite fast.
Mm-hmm.
So they could do it fast. But there is not like many people knowing R, Python, and all this kind of mastering all these kind of softwares. So it's an engineer with a being an expert in a field with the appropriate tool. I mean, the appropriate platform could do it really fast in a couple of weeks or even in a week.
And in this case, then the domain expertise would really be important, right? Because then you're talking about looking at data, but then you actually need to know um, how exactly this could be optimized too.
Yeah, that's an important point, because, for example, you could have one guy that it's really good at doing machine learning and coding and all this, but if he doesn't understand the physical meaning of what he's getting, he could
Mm-hmm.
not do something. So that's the importance of combining both expertise, data scientists and expert domains, in order to get better results.
Mm-hmm. So when you did this, did you have some domain experts supporting you, or you were taking these decisions by yourself?
No, we have some domain experts, and for example, in this case, is even the customer. The customer, they know they know their process. They have been working on it for several years. So you just help them. It's like let's say that you just disclose the data, disclose some insights of their process, and you start discussing with them about the potential reasons for some scenarios or a set of conditions.
Mm-hmm. But you know, I know that Nipun already asked this when it comes to this replacing a production management system. But like when I think about it, if you have a very like I can see the benefit of doing this, but if you already for example in the new industries which are there, I'm guessing that they already have very optimized production management systems which are amongst other things, also responsible for making sure that the process consumes less energy, right? Because that's sort of what they are supposed to be doing. And in that case, I mean, would these be the kind of industries where this wouldn't be applicable, or where you would collaborate with the um, like I'm trying to identify, because for me it's kind of um, making me realize that the more you explain that it's specifically towards improving the process, but then that means that these kinds of data and information, more and more the industry is trying to get this themselves, right? Like every
Yeah,
company would want to use this data and be doing this, and they would also want to do the production management system together with it. So I'm just trying to understand how applicable is this in different kinds of industries.
it's applicable. And just for your knowledge, for example, I participated also in a congress in Frankfurt. It's
Mhm,
called ASHEMA. It's a congress about the chemical industry. And over there, there's an association called Spire, SPIRE.
mhm,
And the main, the objective of this association, of this organization, is to improve the use of resources, not just energy, but also water, raw materials within the industry in Europe. And believe me that there are still a lot of opportunities in this field, even though companies improve. Yeah, I mean and you could see it even in data. For example, in my
Okay.
case, you could see that the customers have improved and maybe 5-7%. But also we have to make us the question: yeah, they improved 5%. At which cost? And how long did they take to improve that? So if you
mhm.
could show that you could improve in less time with less resources, then that's when you get all these people interested on this solution, on this type of solutions.
Yeah, if I can add on that, like Cesar also explained that this is a tool for continuous improvement. So it's valid to ask in what level then the company cannot improve anymore. But I think it's, for example, for in you've implemented this, and your company has reached improvement of 10%. So are we going to stop on that, like, and then not going to do anything else? But there is also a possibility. For example, you have new technologies, and you want to compare your new technologies to the current one to see if you want to invest this. So I think there are always new things that are coming up, and I think this database analysis can help on decision on the future investments as well.
Uh, and also, I would like to add a point. Even though, yeah, it's fast, you could implement it quickly, but also we have to take into account the scale of it. So, for example, we might have a proof of concept in Europe, but maybe that company also have they would have also some sites in North America, in South America, in Asia. So, for scaling the solution, that's another story. For having the same stuff everywhere in the world, that it's more complex.
And I have one more point to add to the question too, that it is not necessarily true in industry that a new process or a new site or a new industrial production would be energy efficient. This is because electricity is a really cheap resource for industries.
Yes.
And then the cost balance of the fact that the production processes or the production equipment which are less efficient and much cheaper than the difference of electricity that they have to pay or they will save if they use a highly efficient process. So even though it is true that I mean I think that there is always a scope for improvement, especially given the fact that industries do not necessarily start new production processes with efficient equipments.
And for example, also we could also mention the SMEs, because they might not have the money to replace their equipment. So they might try to operate always with the same equipment. And so, for example, when by using this kind of solutions, they might boost the performance of their current assets.
And then in this case, how would they pay? Like, for example, would they pay per month of service fee, or is this like a one-time fee that then they have to pay?
There are different business models in this for paying for this solution. But yeah, sometimes it's just one pay. It's just an upfront payment and that's it. And sometimes there's a quite like a service related to it. So that depends on the company and on the service provider, I would say.
So when you set up the advanced analytics tool and this dashboard, it can sort of keep running by itself if the process does not change, like if there's not major changes.
Yeah,
Okay, great.
yeah, yeah, yeah. And here, well, I don't know if there's any other question.
Yeah, thanks, Cesar. Yeah, I think I have a couple of questions. You were also mentioning earlier about the sort of the relevant parameters needed to develop the model, right? The machine learning model. And I think you also mentioned that there are some, besides the data that you get, there are also some tools in the market that help you identify relevant parameters for certain data sets.
Yeah.
Yeah, could you just expand on what those tools can do and what they are?
When I mean tools, I mean machine learning tools. I mean an algorithm itself. So, for example, we could employ clustering techniques in order to identify operating modes, for example. So, within clustering techniques, you might find k-means, for example.
Okay.
So, but for this, there's also there are a lot of other methods, or I could also mention extra trees, for example, extra randomized trees. I like this one because, for example, in this one you might get a quite chart similar to the Pareto chart, where you might find the relevance of each parameter against one output. In this case, as we have already defined our output as the specific energy consumption, uh, So it would be the parameters affecting this KPI. So this, when I mean this is are the kind of tools, and you could do, and for using these tools, again, if you know, if you master Python, for example, or you could code and do it by your own. But if you are not good at coding, as me, then you might try to go to a service, an analytics. You might need to find an analytics platform in order to do so.
Okay, so yeah, these are like supervised and unsupervised learning sort of tools, right? I
Yeah,
guess.
yeah. And depends on the problems you might have. Yeah, when we are talking about clustering, we are talking about unsupervised methods. And for example, what I have presented in the model development, it's the common methodology for a supervised learning method.
Yeah, and also like when you suggest these solutions to your clients, do you basically do an internal sort of comparison between all these sort of machine learning methods to see which one is the best? Or yeah,
Yeah, nowadays there's a little bit of this, and each company might have. I would say that they have already their set of tools. They have already identified which algorithms work well, and just they might need to identify which is the problem, so they might have the solution for that problem. So, for example, if we talk about optimization, there's something called prim. So, okay, I need to do optimization, then I use that one because they have found that that method is the one that it's working properly for the industry, for example. There might be other companies that might use different ones, or that might go and try to develop one. That depends from company to company.
okay. Yeah, thanks. And I guess it's also dependent on the problem you're trying to solve, right?
Yes, yes,
Yeah.
yes. As for example, I have said optimization, but also well, as we have talked before, the identification of relevant parameters, maybe clustering techniques or extra trees would be the solution.
Okay.
So yeah, it depends on the problem.
Yeah. Okay, thanks.
Okay. Thank you, everyone, for the fruitful question and answer session. So, if there's nothing else from the audience, I would like to thank you again, Cesar, for the presentation and the topic. I hope everyone get a good knowledge, get inspired by the new technology from the fourth industrial revolution. So yeah, I give it to us to if us to has another announcement.
No. Just thanks,
Okay.
thanks to Caesar. And for whoever is listening the recording version, don't forget to subscribe to our groups. And yeah, was that keep the notification open so whenever we have some new activities, you can get updated.
Yes, and of course, further discussion is available in all social media we have, Facebook, email. You can ask Cesar for a specific question, or yeah, you can reach any of us if you want to present for the next session, also for the upcoming session. And if you want to get involved in Emanate, we have several ideas coming up, like websites, podcasts, and other interesting interesting upgrade. So thank you for listening. Thank you for joining our Emanate session. And wherever you are, have a nice day.
Um, Thanks to all of you.
Thank you, Cesar, for the great presentation. It was really helpful to understand your work. And thank you, Andre and Astu and Nipun and everyone
Hey, thank you, everyone.
Thanks,
Also.
Nikita. Thanks, everyone. Bye bye.
Yeah,
Bye
bye.
bye.